Hello and welcome back to K-Tech Designs. My name is Seth. In this video, I will demonstrate how I use the spreadsheet feature in FreeCAD to make configurations and to drive dimensions and other parameters. The model I'll be using for this demonstration is this cable management clip. I'll just show you quickly. You can configure from 2 to 5 clips very easily. You could expand this to any number that you like. And with that, let's get started. So always from the start page, and you can see which version of FreeCAD I'm using. Click Create New. We're going to create a part container, and in that part container, we're going to create a body. Now we need to insert a spreadsheet, so we'll go down to the spreadsheet workbench. This creates a new spreadsheet. I'm going to see if I can trick this into... Well, I was going to see if I could trick it into going above the body. Let's just delete the body. I'm a little bit anal retentive about organizing models, so I just like to have the spreadsheet on top, and that way any new feature can flow from the bottom and the spreadsheet doesn't move around. So the spreadsheet does need to be inside this part container in order to drive the configurations in the part. Let's go back to the model and make that body there. Okay. Make sure that's in the part. That's right. Should have double clicked the part in order for that body to get created inside there. Don't worry about that. Now let's set up the spreadsheet initially. So the way configurations are going to work is there's going to be a configuration name here, and there's going to be parameters like named dimensions or calculations you'd want to use to drive, let's say, a linear pattern. And we're going to have to create what's called an alias in order to reference that. So let's start with our column headers. I'm going to go with config name. Config name. Let's go with clip width, clip count, clip spacing, and we'll go with rail length. Now these are just the column headers to give me a reference for what I'm going to put in each column. Let's go with a clip count 2. Just plug in some numbers, it doesn't matter. We'll update that later. No, that's okay. Then let's just copy this, paste it down here. So from here on down will be the actual configuration names. And this row will represent the currently selected configuration. So now we need to create our aliases. Let's call this one clip width. Okay. And you can see that this cell changes to yellow once you give it an alias, and that gives you an indication that you can reference this cell value somewhere in the feature tree. Let's call this one clip count. This one will be clip spacing and rail length. Now this cell name is very important because this will create a parameter inside of the part called configuration, which will allow us to select different configurations. So let's right click on this cell, and we're going to create a configuration table, and the property we're going to call it is configuration. And I don't believe I need a group for that, so we'll just click OK. Possibly I do need a group, so let's try that again. Right, that's what I missed. Property should be part.configuration. That way your you're saying that this configuration is at the level of the part. Now let's click OK. And now if we go to our part, we see that there's a new property called configuration, which has a drop down for configuration. So if I was to take this, let's copy it, paste it here, call that 3, recompute that. Now if I go back to my part, you can see I can now select a clip count of 3. And I find it important to set up the configuration table first, because as you're building the model, it's more convenient to go ahead and reference the dimensions or the counts that you need instead of creating the entire part, making your configuration table, and then going back into the part and resetting things. But if you have to do that, like you don't know how many column headers you need, you're not exactly sure what you're going to do, then don't beat yourself up about it. You might have to take that extra time to make the part first, build your spreadsheet, and then go back through. Okay, so these configuration properties are going to be a bit arbitrary, but the count makes sense. We're going to do 2, 3, and let's just copy this. 4, 5, 6, and 7, and then of course we'll just do 4, 5, 6, and 7 because that's the number of clips. And our clip width is not going to change, but it is a value that I'm using in a calculation over here, so that's why I've included that column. Now the clip spacing, this is for the linear pattern that we're going to use. And the way the linear patterns work in FreeCAD is not by setting a quantity and setting the spacing between those quantities, between each quantity. It sets the start to finish length, and then your quantity will divide that length. So in order to create the correct clip spacing, we need a formula of, let's go with equals clip width. Let's try this again. Equals B4 times, we'll go with the spacing. I always get this wrong. Apologies, let's try this again. Equals B4 times C4 minus 1 to give us 14. This is not Excel, so that always makes me confused. We can click Control C to copy and Control V to paste, and it will honor the row. Next, let's set the overall length, and it's just going to equal B4 plus D4. Alright, so actually our config table is all set up now. Let's not worry about that, I guess. Let's go to clip 2. And why is there a none? Interesting, I didn't know I could do none. Okay, we'll just leave that alone. I'm going to start with a primitive additive box. That's fine right there. Let's select the bottom plane as a reference. Change the length to 14. Actually, we can do the formula now. So what you want to do is type in spreadsheet. And this is the name of the spreadsheet in our feature tree. Let's type in rail length because that's the overall length of the part. 28. And click. Let's make this 16. And this will be 14. Now this we could also set up to be spreadsheet.clip width. Now I don't really want this box to be, well, I want it to be symmetric on the axes here, so I'm going to move it around really quick. Do -7 on that. And -8. Let's click a new sketch just so I can see where the planes are. Yes. All right. And I want this to be overlapping a little bit, and you'll see in a second when I model the cable through hole. All right, great. Now, honestly, if we go here, we can already see that some of the parts will be working because we've set up that configuration. Go back to 2. And let's build our show the body here. It's interesting. Okay, there we go. Not that I really need to see it, but let's build our cutout. So let's start with a circle on the axis here. Of course, I'll now hide the box. I'm going to create a reference line over here, make that horizontal, and horizontal to there. Let's make an outer arc coincident to that. Then take a line up here, over here, and down. And I'm just going to make these horizontal. So that's locked in place. Now referencing the body, we want to have this over here because this will be our cut. That looks good. Now I want this center to be 7.5 millimeters from the bottom. And I want this leg to be, oops, let's pick the right dimension, 3 millimeters. And this outer radius is 14. Sorry, that's a diameter. So then let's divide this by 2. That didn't work. Let's just type in 7. Now let's check our box. That looks okay. Now we're not done. We do need to create an opening here, and we're also going to trim out some of this stuff down here. So let's begin with a construction line going radially from the center, and then I'll create a parallel line to that, and I'll set this at let's do it from here. Instead of setting an angle, let me just set a distance, and I'm going to make it 1 millimeter, meaning that the total opening will be 2 millimeters as we make this symmetric. So I can grab this line, this axis, make that symmetric. I'm going to go ahead and make those connected. And I'll make these symmetric. Now let's take the trim tool and remove those inner faces there. And I also need to remove this face because the cutting area should be this. And that's reference. Make these symmetric as well. And then I'll simply set a height of, dimension to a line, 15. Let me just check if that's high enough. Yep, that's high enough. Something doesn't seem quite right there. This seems a little bit taller than it should be. And it's possible that I missed to mention the box. Yes, this should be... Gotta clear that actually. 14.3. There we go. So now one thing I do want to add though are some fillets here. And the reason why I want to add sketch fillets is because there's such a big problem with FreeCAD and references, face references, entity references, the naming reference issue, that it's just going to be easier to have these fillets in the sketch. So I forgot to add those. No problem, we can add all of these references back in. Selecting all of the fillets at once and then setting a radius, we'll set them all equal. And I'll make it, 0.5 is okay. So then we need to re-add our constraint here. And I'm going to create an intersection point. So let's make a line from here to here and here to here. This line needs to be tangent with this arc. Unless it already is, but I don't think it's already tangent. There we go. And then U should be parallel to U. And now you intersect these. Apparently not selecting properly. There we go. Now that's all fine and good. We lost that reference, so let's pick those points. Okay. How else is it free to move? Must be on this side, so let's mirror this actually. Grab these two, grab our center line, mirror those points. Gotta bring these together. Make this line and this arc tangent. Make these parallel. And then finally, get out. We'll make those symmetric. Now, of course, we lost our symmetric constraint over here, so I'll just pick the centers of the circle as the reference for symmetry. Okay, we got our fully constrained sketch back. Let's click close on that. We can show our box again, and we can do our cut. I did do this incorrectly, didn't I? Let's move this sketch out. I know it's a little bit wonky, but let's just move that out to 8 because it's 16 thick. And then we'll cut that through all. All right, perfect. And now we can create our linear pattern. So we'll take the pocket, select a linear pattern. We want the x-axis. All right. We can set our occurrences to spreadsheet dot clip count. We can set our length to spreadsheet dot clip spacing. There you go. And click OK. And now you're pretty much done. But there are some things that we could do to clean this up a bit. And that would be, let's rotate that over. Adding a cutout here to make the cable slide in a little bit easier than this. This will be a little bit too square. And so an easy way we can do that is to create a sketch on this plane. Close it there. Okay, spin that around a bit. And we'll work from the left. Hide that again. Let's create a circle on that axis. And we'll let's add this as our reference. Let's go back. Let's try polyline. I don't use polylines enough. And then over and then down. Hit escape to cancel. That next line. I want these coincident. I thought that was the correct. Oh. I'm just editing from the wrong side. There we go. Make sure everything's connected correctly, like that. Now let's make this, let's add a point here so I can dimension to the top of this circle. Okay, make those coincident, and from the top of the circle to the axis, I apparently had more things selected than I should have. Let's make that 15. Let's make you, actually, why don't you make those two tangent? That would be perfect. The diameter of this part should be 16, which of course is the width of our clip. And we'll dimension these just 1 millimeter above, just to make sure that we clear that part. And then we trim off the bottom that we don't need. Trim that. Okay, I'm struggling. There we go. And again, I'm just going to set this to 7. Negative 7. And we'll again cut through all. Perfect. Now you see that I did cut a little bit above. It's not a complete circle, and you can do this whichever way you want, but I really just wanted to round this edge, and you can't really do that with a fillet feature, of course. So this cut works for that, and it's through all, which means that every time that we update this part, that cut will find its way all the way to the end. And that's it. That's the basics. There's some things you could do, like fixing these edges, or treating these edges with a fillet or a chamfer, but it's not a really good idea to do it in FreeCAD, because even though these are always going to be the same edges of this box as it grows, the named reference is going to change, which is a real pain in the butt. And if you're going to 3D print this, which is what it's designed for, you don't have sharp edges like this, especially in this orientation. So you could get sharp edges here as the tool hits these corners, but I'm printing it out of a flexible material. So even though it may be a sharp edge, like a layer's edge, it's going to be soft. And it's not a big deal. But it's something to consider. Another thing you could do, and I don't recommend this, but if you really wanted to have those rounded edges, is to create a cut feature, kind of like we're doing with these other pockets for the chamfer or the fillet there. and you drive the length between the cuts inside the sketch with the spreadsheet. So no matter what length you're choosing, it's always going to place those cuts here. And that's fine for the corners, but then how do you take care of these? And you can do it sort of. So if I go back to this pocket and I put it, let's see, you might want to have this first before the linear pattern, but it doesn't really matter. If I want to put a chamfer in here, I know it's too big. Let's try 0.2. Okay. Well, that's another issue with FreeCAD chamfers, is they really don't like things that are a little too complicated like this here, because really what it's looking for is it's noticing that this edge is tangent, so all of these are tangent. So technically if I was in SolidWorks and I click this edge and I try to chamfer it, it would try to do all of this. Okay, and it's mathematically tricky to do that, if not impossible. So a lot of the dress ups I've just resigned myself to not really have when it comes to FreeCAD. But that was a bit of a tangent, so I digress. Now the model is complete. Now I showed you how to use the spreadsheet table to create alias ranges, and how to use the configuration table feature to create configurations. I hope you enjoyed that video. I hope you got a quick and easy introduction into configurations within FreeCAD. It is a very powerful CAD feature to create configurations. You know, you can create the basic concept, the basic design, and then easily configure it for a wide range of applications. Alright, so that's it for this video. I hope you enjoyed it. Please leave a like if you liked it. Please leave a comment to let me know what you thought. And again, thanks for watching, and I'll see you in the next one.